Fine. Next, we'll start with similarity, students, in the chapter 15. The chapter is similarity as a size transformation. Let's see what we have. Did they do this chapter in your school? Chapter 15, similarity as size transformation. Because no questions have appeared in board exam. So you'll have enlargement, reduction, and same image. Identification transformation. The transformation is an enlargement. Transformation is reduction. Okay. Transformation, identity transformation. Then related to model, map, and images. Okay. Similarity of a size transformation. Yeah, Charisha, why are you late, Charisha? You're late by 10 minutes. Yeah, good morning. Why have you joined late? 10, where is it mentioned in group? Then, how can you think, Charisha? I told 9 o'clock, then I felt 9 o'clock is a bit early, so I kept it at 9:30. I thought 9 o'clock you all might delay, even 9:30 also you are joining late. Okay, we'll start with the students. All of you, can you see the screen? Is it being shared? Similarity as a size transformation. Fine. Tell me this, students. Whoever had concentrated, what is similarity? Similarity as a size transformation. Any idea about this chapter? Any idea about this chapter? Respond, all of you all. What do you mean by similarity, students? What is similarity? Similar in terms of what? See, this is geometry. It comes under geometry. Okay, let me take any two figures, a triangle, a small triangle, and a bigger one. The meaning of similarity is same shape. They have same shape but not same size. Same size is not required. If both are same shape and same size, that we call it as congruency. That is congruency. So this chapter is not about congruency, it is similarity. The meaning of similar. See, similar and same, both are different. Similar is it kind of looks same. Okay. In terms of shape, it is same. In terms of shape, this is same, but not the size. Size, the values are different. If both are same, that is congruency. The topic is congruency. Now, similarity, any two objects that can be triangle, rectangle, square, circle, any two, same shape, but different size. They don't have same size. Fine, that is known as similarity. Or even if they have same shape and same size, that is also known as similarity. Even that you call similarity. But in this chapter, we'll have just the same shape, students, not the same size. So what do you mean by same shape? What kind of shape are these? What kind of geometrical figures? Triangle, I name it as ABC. I'll name this as DEF. So the meaning of similarity is all three sides should be equal, students. All three sides, the values. Same shape should be there. If AB is 5 centimeter, do you think DE will be 5? Respond. Do you think DE will be 5? Look at the length. No. Okay. So let me take it as 10. If BC is 6, I'll take this as 12. AC is 7, I'll take DF as 14. So from this we got to know the first triangle values 5, 6, 7. The second triangle is 2 times the first triangle, student, twice. Okay, it is twice the first triangle. This is known as similarity. Fine. All the values will be of same. If you take 5, let me take AB. AB is equals to 5. Smaller triangle. Next, bigger triangle. What is bigger triangle value, students? What is DE value? DE 10. Now what I would do is I'll keep AB as it is. If I divide them, if I divide AB, I'll keep 5 by 10 as it is. I'll shift DE to the other side. DE. So when I divide both to get the ratio, DE goes to the other side. Or if I take ratio here, what is the value? 1 is to, tell me, 1 is to 2. Can you see all the values are 1 is to 2, right? In smaller triangle, BC is 6. What about EF? EF is 12. 1 is to 2, right? Double. 1 is to 2. So this is the ratio, students. Now if I reduce this, AB is equals to 1 by 2 into DE. This is known as scaling factor, which means the ratio of their values. This is how we get. We get it through the concept of ratio and proportion. This concept follows ratio and proportion. That is not required. Just remember the formula. AB is equals to half into DC. Okay. AB is the smaller image. Half is the scaling factor. Scaling factor is nothing but ratio. Scaling factor. So take down these words, scaling factor or K. We basically name it as K. K stands for scaling factor. So the shape will be same, sizes are not same. And each side you take, it is of the same value, 1 by 2. Now look here. Imagine 12 and 14 is not given, students. Only 10 is given. What is the scaling factor we got? K value. Respond all of you. What is K value? K is equals to 1 by 2. We got K is equals to 1 by 2. Left hand side, which value? Is it smaller diagram value or bigger diagram? Smaller. Right hand side, right hand side, the bigger diagram, right? The bigger diagram value. Smaller and the bigger one. Now scaling factor is 1 by 2, students. I'll use this 1 by 2. We got the through one side. From one side we use the ratio, we got the scaling factor. Now if I want to find BC and EF, so take smaller diagram. BC is equals to, use the same scaling factor. Half of BC and EF are related. EF. We know it is 12, but let us check using the formula. BC is equals to half of EF. BC is equals to 6. 1 by 2 into EF. What is EF value? How do you find EF? If 2 goes to the other side, EF is equals to 12. Is it double? Response, students. The value is double, right? Because of the scaling factor. The scaling factor is 1 by 2. For this question, not for all. For each and every question, scaling factor will differ. Now next, if I want to find the third side, how do I find the third side, students? AC is the smaller value. AC is equals to, what's the scaling factor? Yes. So what I do, I'll write K. K into DF. This is the formula. Later I'll explain what is AC, DF. Those are sides. Basically, those are sides. And what type of questions you'll have? Okay, I think you'll have only area, sides, square, students. Sides are given, area is given. Volume. No angle. Right? Angles are not given, only sides. Next. When we talk about same shape, the values will be different in similarity, but the angles will be same, students. 60 degree, this also will be 60. If this is 70, E also will be 70. In detail, I'll explain in the next exercise. 60, 70, 110. 60, 70, 130, 50. So the angles are not changed in the, what is it? Similarity as a size transformation. Remember, angles are not changed. If the angles are changed, you get a different value. You won't get the same value. Okay, angles will not be changed. For now, just ignore. Remember this concept. This is the formula. K stands for scaling factor. K is the scaling factor. Use the same formula. AC is equals to, what is K value we got? 1 by 2 into, tell me students, 1 by 2 into DF. What is AC value? What is AC? 7. So what's DF value? 7 twos are. Just put the value of K, scaling factor. So scaling factor we got through this. Any one value will be given. Remember, any one value will be given. AB and DE is what we took. AB and DE. Okay. According to the value will change. Right. So you find the scaling factor and you get the answer. It is basically you check how many times the value is increased, students. How many times the value is increased. And the practical application of this is practical application. One more thing, there are two diagrams given in your textbook. I'll just quickly explain the basic one. Not only this, even square and rectangle. See, square, two squares together, they are similar. Angles are same. All four are 90 degrees, but the values will be different. Now let me take one square, ABCD. This is not required, but just in reality, if you take a point here, students, if you take a point outside, I'll name this point as P. From P, you connect it like this. These four figures. Imagine P to C. P to C, it is 5 centimeters. P to D, 10. Okay, I'll take everything as 5 centimeters. 5. If I want to enlarge this, there are three words you have to remember. Enlargement, enlarge, reduction. The meaning of enlargement is increasing the size of the object. We increase the size. Meaning of enlargement is increasing. I'll give positive. Plus. Reduction meaning is negative. Minus. You're reducing the size. Now from point P, look, ABCD is a square. Now what you do, A to D, students, A to D is 5 centimeter. Sorry, P to D is 5. From P, take 10. Take 10 centimeter, draw a straight line, connect this D. We'll get an enlarged value. Then A to P is 5. A to P. From P to, I'll write this as D dash, C dash, A dash, B dash. Right? Now from P to A, 5 centimeter. What I'll do is from P to A dash, I'll extend this diagram. If that is 5, this distance will be 10. Double the size if I double it. In the same way, P to C is 5 centimeter. P to C dash, I'll keep a straight line. I'll keep a ruler and I'll draw 10 centimeters. If I extend. In the same way, B. Then I'll get a figure A dash, B dash, C dash and D dash. The bigger diagram. Nothing. Look here. From point P to D, 5 centimeter. I'll just double it. I'll take 10 centimeter from point P. I'll draw a straight line. 10 centimeter from point P. Look at the pink line. Then in the same way, from point P to A, it is 5 centimeter. So from point P, I'll take 10 centimeter and draw PA dash. In the same way, if I connect, I get this yellow diagram, students. This yellow diagram. Now, if the smaller value are 3, 4, 4, and 4. This is the concept of enlargement or size transformation. Look, all four, this, it's a square. All four sides are equal, 4 centimeters. If the length is doubled, even the value also will be doubled. Look, from P to D it is 5 centimeter, but P to D dash 10 centimeters, which means each and every side would have been doubled. You'll get 8, 8, 8 and 8. This is the concept. Is this clear? All of you understood? Distance. See, P is nothing but some distance. Imagine you're standing at point P. Point P. Okay, P to B. P to B is 5 centimeter. P to B dash. B dash will be 10 centimeter. So the distance from P, it is everything is double, students. The distance from P to this yellow square, everything is double. Therefore, the value is also double. This is the concept of enlargement. We have enlarged the square. Enlargement. Reduction is just half of it. Reduction is half of it. Okay. Now, how do you find scaling factor for this? How do you find scaling factor? Look here. Suppose we don't know the values here. Just 8 is given. Just A dash B dash is 8. Just A dash B dash is 8. Look at the 4. The sides of all the four sides of a square 4 centimeter. And A dash B dash only one value I've given 8 centimeter, students. 8 centimeter. Let us take the scaling factor. Which is the original diagram here? Which was the original diagram? The smaller one or the bigger one? No. Bigger one is what we got. That is not the original. Which is the, yeah. With which reference we drew this? We got the yellow diagram, students. Which reference we took? The smaller one, right? Yes, smaller one. So always so we call this yellow one as the reflection or mirror image. Reflection or mirror. Or you call it as object. We call it as map. Call it as, what are the different ways? Model. Model, map. Okay, then what are the different names given? Image. Image, not mirror, image. Image, map or model. These are the three names, students. Image, map or model. Image, map or model. The original diagram, we take it as object. We call it as object or pre-image. Object. Okay, so whatever new diagram is formed, students, with reference to this new diagram, image, model and map. The formula is image. I'll take image divided by, if I divide it, divide by the object value. Now let us take the size. In image, which size is given? Which side value is given in image? Which side value? A dash. Respond, all of you respond. A dash B dash value is given, right? A dash B dash divided by, in object, take the same side. What is the same side, corresponding side? AB. What are the values? A dash B dash is 8 divided by 4. Now look here, image is equals to, I'll shift this. If I reduce, what do we get, students? 2. I'll shift the object that side into object. This is how we get the K. K is the scaling factor. What is the scaling factor here? K is equals to, respond. K is equals to 2. So the image is equals to 2 times the object, students. Isn't it clear? Image has become twice, right? Twice the size. You read it. You read the sentence. Image is equal to, see, if I convert into sentence, image is, that is the yellow one. Image is twice its object. Twice of its object. So the scaling factor is 2. Okay. Scaling factor is 2. Remember, the new image, whatever is formed, that should always be on the left hand side. In the formula, left hand side, image. Image, map, model. All the new image formed should be on the left hand side. Right hand side is the original value. Original object value, what we have taken. So image is twice of its object. The scaling factor is 2. We have got the scaling factor as 2. Okay. Now we need to find A dash D dash. Which is the original image, students? Which is the original image? AD or A dash C dash? The yellow one or the black one? Which triangle? Original one. The black one. The original should always be on the right hand side. We'll take A dash D dash. A dash D dash is equals to K into original value AD. See, A dash D dash, we got reflection because of AD. Now, if you want to find a dash d dash, a dash d dash is equals to what is scaling factor we got from the first question? What is scaling factor? 2. Into what is AD value given? 4. What's the answer? Which means original. No, no. Right hand side original. Always remember right hand side original. Left hand side is the image, map or model to the form. Is this clear? All of you understood? If you calculate, you get 8 students. Can you see all the sides are doubled? Everything is doubled here. Everything is doubled, right? It's a square. Everything is doubled. Any doubts in this, students? Do you all have any doubts? Yeah. Entire thing I've explained, but only formula is important. We use the formula and we'll solve. Yeah, Joanna, half an hour late. Is Joanna online? Okay, fine, Joanna. See, this is a very important topic and very tough as well, Joanna. So the first half an hour was very important. Okay, I'll upload the recording. Will you watch and attend? Join evening? If not, it's not possible. Okay, it's not possible to solve the next one, Joanna. You need to concentrate from the beginning. Yeah, fine, no problem. 11:30 or 12 o'clock, I'll upload the recording. Watch that and join evening. Okay, you can leave because I've started new chapter. Okay, you can leave. Log in at 6 o'clock evening. Join at 6 o'clock. Okay, bye, Joanna. You can leave. See, from the beginning, if you concentrate, you'll understand, students. If not, it is going to be tough. There's no point in solving without these concept, diagram concept. Okay, now the formulas. Image, we call all the original value, we call it as object. Take down the different names for original value, we call it as object. Object or pre-image. Whatever we explain now, students, even if there is confusion, just ignore. Only the formula is important now. Next. Original value, we call it as image, object or pre-image. And the resulting, whatever transformed, whatever this original image is transformed, whatever this original image is transformed into, we call it as, see, the original object, we call it as pre-image. That after transformation, the transformation is of 3 types. I'll explain that. It can transform into 3 types. After transforming, we call it as image, model, okay, model, map. These are the 3 types: image, model, and map. So the transformation of 3 types. Here, what kind of transformation had taken place? Did we enlarge or reduce the diagram? From black to yellow, was it enlarged or reduced? Enlarged. So the 3 types are enlargement, reduction, and the other one is identity transformation. Identity is same. Enlargement. Enlargement. Here K, the scaling factor will always be greater than 1, students. What is the scaling factor we got here? K is equals to what? Respond all of you. K is equals to 2, right? Isn't it greater than 1? It is greater than 1, right? In enlargement factor, in enlargement, students, the value of K factor is greater than 1. Then reduction. In reduction, the value of K is less than 1. Then we also the third one is identity. Identity meaning is same. So K will be equal to 1. MCQ questions. Identity K is equals to 1. These are the concepts. Enlargement K is greater than 1. That is, K is nothing but the scaling factor. Reduction K is less than 1. Identity K is equals to 1. Make a note of this. So without the starting concept, whatever I explained using diagram, if you go through this, you will never understand what is image, model, what is enlargement, reduction. It is not possible. Those who still have doubt, I'll upload the recording, students. Try to concentrate from the beginning. Those who missed out any concept, try to concentrate from the beginning once again. Go through the recording. If not, it is too confusing to solve this chapter and the next chapter. Next, let me take the original image. Original image, I'll take it as A, B, C, D, 10. It's a square. Each side 10 centimeters. Original value. Yes, all of you will concentrate. Concentrate. Now, one example. Now, what I'll do, I'll keep a point P, students, P. This point. Or just imagine you're standing at point P, you're looking at the values. So, all these values lines get connected here. This is the original image. Original image will always be given like this, students. A, B, C, D, E, F. No dash will be applied. For the transformed image, we call it as transformed image, model or map, A dash, B dash, C dash, D dash. Dash will be given. Dash. Fine. Now this. What I'll do, I want to reduce the size. I want to reduce it. If you reduce, it would lie somewhere here. B. Now the distance between P to C, I'll take it as 20 centimeter. Distance between P to C. I want to reduce it by half, students. Half. So the distance between P to C dash here, if I join the points, I'll get another square like this. C dash, D dash, A dash, B dash. Fine. So the black one is the original image, original one, object or pre-image. The pink one is the transformed image. How is it transformed? The size is reduced or enlarged? Respond all of it. Is it reduced? Reduced. What's the value, students? What's the value of K? It should be less than. Let us check. I'll give any one value. DC is 10. I'll give D dash C dash as 5 centimeters. 5. What is the formula I told? Left hand side, you should have original image or transformed image. Left side, it is always transformed image is equals to K times original, original image. Original image, transformed image is just for explanation purpose. So what we do is from the transformed, you take side into is equals to K into original side. Which side is given in the transformed image? Which side value is given? D dash C dash is equal to K into, first we have to find the scaling factor, into what is the original image? D dash DC, just DC, students. Now tell me the value. Respond. What is D dash C dash value given? 5 is equals to K into 10. How do you find K value? What happens to 10? What's the value? 1 to 0.5. What is the value? Yeah, 0.5 is for you all to understand. Isn't it less than 1? This is the fraction. We need fraction, students. Remember, we always need fraction. What is K value? 1 by 5. This K value is enough. Now look at this. This is the concept of transformation. See that this is what makes maths interesting. Using this K value, we can find all the other values. I've taken 5 and 10. 5 and 10 is a very easy topic. In your questions, you have 1 is to 1000. Sometimes it is increasing 1000, 2000, 10,000 times. If you know this concept, everything is possible, students. You can take down, you can make a note of all the transformed images value. Now let us take AC. I want to find A dash C dash. This is the transformed value is equals to K into original image is AD. What is A dash C dash value? It's not given. Let us keep as it is. What is K value? Respond all of you. K value is, tell me, K value is 1 by 2 into what is AD value? Original value AD. AD is 10. If you reduce what you get, A dash C dash will be 5. This is formula. So take down this transformation or transformed image. Transformed is equals to original. K into original. Make a note of this formula, all of you. Transformed is equals to K into original. Transformation or transformed image is equals to K. K stands for scaling factor. That is the ratio. into original image. Then I explain what is k value. For reduction, reduce, it is always k less than 1 students. Identity is same. See, identity is nothing but if I have a square, the same shape will be formed. Same shape and same side. The point P will be here. So from here you connect it. Basically same students, everything will be same. Size also will be same. That is known as identity. Like identity twins, everything will be same. Objects, same shape, size, angles will be same. Mostly we don't take this when we are solving enlargement or reduction. We just solve question based on enlargement and reduction. K is equals to 1 by 2. This is the formula. Transformed is equals to K into original. Is it clear? All of you understood? Now, last year we had studied few units, students, units. If all of you remember, A, B, C, D. What are the units we take? For side, what are the units we take? Centimeter or centimeter square? Take a centimeter. Centimeter. For area, very good. For area, it is centimeter square. For volume, cube. Can you see the degrees? Remember this, students. Perimeter, side. Look here. Perimeter. I'll tell you why this is important. Perimeter, side, breadth, length, diagonal. For all this, it is just centimeter. The degree is only 1. The degree is 1. For area, what's the degree? For area, it will be centimeter square or respond. Centimeter square, meter square or kilometer square, right? That is area. Centimeter, meters, kilometers. Centimeter square, meter square, kilometer square. The reason is, what is area of a square, students? How do you find area of a square? How many of you remember? What's the formula? No, that is perimeter. Perimeter. Area is equals to side square. Side square. Very good. Side square. What is each side? 5 centimeter into 5 centimeter. 5 5s are 25. What is centimeter into centimeter? What is x into x? X square. Centimeter square. Can you see for area we're getting square? This is the value. In the same way, cube, students. If I take cube volume. Volume of a rectangle is length into breadth into height. How many times are we multiplying to find volume? 3 times. That's the reason you get centimeter cube, meter cube, kilometer cube. So perimeter side, you get only centimeter. Degree is 1. Area square, volume cube. Is this concept clear? All of you understood? Any doubts in this, students? Do you all have any doubts? Now next, transformation. What do you mean by transformation? Do you know the meaning? Transforming from one image to the other one, right? Basically, transformation meaning is what? Change. So what are the different types, students? What are the different types of changes we can see in an object? What are the different types of change? In this example, what are the different changes you all saw? The sides are being changed. Respond, all of you all. Sides are changed. If side change, what about area? Area also will change. If area changes, volume. When we take 3D figure, volume also will change. Right? See, this is one cup of tea or water. This is another cup. Which one will have more water? Which cup? First one or second one? Second one, which means the volume is more volume, right? Yeah. In practicality, study, in reality, this is the concept. One cup, think the volume is 10 meter cube. This is transformed, larger cup. So volume is greater, volume is more in the second cup. Therefore, volume is also changed. The cup shape is changed, sides are changed, area is changed, volume is also changed, enlarged. So basically, there are two types: enlargement, reduction. Right? And I'll tell you practically where we use this. So these are the three types of changes: side, area, volume. And for these three things, we have formulas. For side, look here. For side, transform image side is equals to k into original image size side. Next, for area it is not k. For area, look here, area of transformed image is equals to k square. Whatever scaling factor you get, you have to double it. For example, k is equals to 5. For area it will be doubled, k square into area of original figure. For volume it is tripled. Everything is based on this concept. Everything is based on this concept. So whether it is perimeter, side, diagonal, use the k value. For area, k square. For volume of transformed image is equals to k cube into volume of original image. Take down these three formulas. Make a note. To remember this, I even explained you why k square for area, why k cube for volume. For volume, cube it. For area, square it. That's it. Now I'll tell you what is important. All this was concept, students. Just the concept what we studied. These three things are important. Transform side of the transformed image. Is this concept clear? All of you understood? Respond. Okay, now I'll tell you what is important. Just take down this. Skip other things. Transformed image or transformation. Transformed image. We also call it as pre-image. Is equals to, or not pre-image, transformed. See, transformed is equals to k into original. This is the formula, students. K into original. This transformed, you call it as image or model or map. Image or model or map, fine, is equals to k into original value. Transformed is equals to k into original. We use this, fine, we use this formula for diagonal. Remember, k value, whenever diagonal is given, diagonal value, we use only k. Diagonal, side, length, breadth, height, all these things, height, perimeter, for all this k. Next, same concept, transformed image is equals to k square into original image, original. This is for area. So I'll just add a word here. Area of transformed image is equals to k square into area of original image. Area of actual figure, original figure, anything. Area of actual. This is what they've given in textbook. Area of original or actual, right? Anything. Next, when it comes to volume of transformed image, take k cube into volume of actual image, actual figure. Fine. So these are the different names you give: area of transformed image or area of model, area of map. Model, map, transformed image. All this on the left hand side. Or in simple terms, you can even remember this as duplicate images or derived image. We have duplicated. Right side comes the original, left hand side is duplicate. Transformation, duplicate, original, map, model. These are the terms you have to remember. Make a note of this. Be quick. Up to 11 I'll conduct students. Another 5 minutes. After that I'll give you a break. Is this clear? All of you understood? Then what will be the K factor, students? For reduction, for enlargement, what is K factor? When something increases, K will be equal to 1. For reduction, less than 1. Very good. For identity transformation, yes, K is equals to 1. Identity. So I have explained each and everything. Even in textbook, they haven't explained like this. The information what they have given, you read the textbook, you won't understand. I've explained in such a way, so you shouldn't skip any topic in this. Only 5 or 6 questions will solve. Mostly by evening we'll complete this chapter, and tomorrow we'll start new chapter. Okay, transformation. Fine. What else? Something I had to explain. What else was left? K factor I explained. Model, map. Next. Model, students. The meaning of model or map. I will see in Indian map. All of you have seen map, right? Indian or world map in geography. That is scale. That is enlarged or reduced. Map. How can it be enlarged? Adya, you know the original size of India, right? How big it is. But what they do in map, they reduce it to the size of a notebook, right? Paper size. Or have you seen a globe, students? Globe. Actual Earth is so big. What have they done to globe? They've reduced the size, right? Reduced it. These are the concepts. This is where we use these concepts. So in future, if you take studies such related to geography, or even in physics also this is important. Engineering, I studied all this: mirror image, reduction, transformation, enlargement, scaling factor. So basically, if you see our map, world map or India map, it is reduced, reduction. So K value is always less than 1 for that. You take a globe, it is reduced. Next, model. Model can be increased or decreased. Have you seen this Taj Mahal model? They sell like toys, Taj Mahal. That's a model. We call that as model, meaning replica or remake. Replica or remake. When you remake a big object into a small, we call it as model, students. Map is different, model is different. So Taj Mahal is totally big. We convert into small model, reduction. Next, in engineering, when I studied engineering, we directly don't create a car. We directly don't create a car. First, we create a model. Okay, basically we create a model. Even in physics, you'll have had projects now. You basically create a model of a small car like this shape. Okay, you create a model, you test it. For testing purpose, you create it because the cost will be very less to create a small one. This model, if you want to convert into car, actual image or the original into a bigger car. Now, what is happening, students? Transformation. What kind of transformation is happening? Reduction or enlargement to the actual car? Enlargement. You have to you're increasing the value, enlarging it. That those are the cars which we see on road or which we buy. Okay, which we buy, those are enlarged. Those are not the actual one. We always start from the model cars. Model is the smaller one. Once you enlarge, that becomes big. This is where we use the concept. If you take this concept, size transformation, almost for each and everything we do the same thing, students. Each and everything we do the same thing. Okay, so those who want to become a designer, for example, you directly don't print a t-shirt. We don't print a t-shirt. First, a rough diagram is drawn. Okay, somewhat like t-shirt shape. First, a rough diagram is drawn. This will obviously be small. Material. We'll choose the material. All the designers they'll choose the material. That they'll enlarge the value. Enlarge. That they'll enlarge into the t-shirt or coat or jeans, whatever we wear. That is known as enlarged transformation. Fine. Is the shape same? The shape will be same, right? Respond all of you all. Shape will be same, but the size will be bigger. Same for car. Same for the Taj Mahal example which I gave. The shape will exactly be the same, students. Okay, but the size will be bigger, enlarged. This is the concept of enlargement reduction. If both are same, identity transformation. Everything clear? All of you understood? Take 10 minutes break. We'll start solving the question. Up to 11 I'll conduct. Okay, all of you online? 3, 4, okay, 1, 3, 4, 5, 6, 7. Who's missing? Naomi. Is Naomi online? 7, 8. Okay. Shall we start solving, students? Shall we start solving the questions? For 20 minutes and other questions. Look at the first question. Whichever is increased, enlargement. Whichever is decreased, reduction. Yeah, look at the first question, students. What is given here? ABC, which side is enlarged? After enlargement, can you see A dash, B dash, C dash? Is it enlarged or reduced? The image is enlarged or reduced? Enlarged. These are the keywords. Now look here. Let me draw a small diagram. This is for reference. AB is 3.6, BC is 4.5, AC is 6 centimeters. All three are different. It is enlarged. Enlarged meaning is the size is increased. A dash, B dash, C dash. Such that the largest side of the enlarged triangle, which is the largest side in the smaller triangle, students. In the smaller triangle, which is largest AC, corresponding to that, which is largest to the A dash, C dash, that value is what they have given. 10. First, what do we need to find here? Scaling factor. Simple. Draw this diagram. Now, what did I tell you all? Transformation. T is equals to X into O. Transformation is equals to original, right? Okay, what is transformation value? A dash side. Compare the sides. A dash C dash is equal to K into AC. 10 is equals to K into 6. What is K value? This is the scaling factor. All of you understood scaling factor? Yeah. Next, what do we need to find? Find the length of other sides. Other sides, which one shall we start? Which side shall we? Okay, what is A dash B dash K into? What's the corresponding? AP. What is A dash B dash? Keep it as it is. What is K value? Into 3.6. 5 into 1.2. What's the answer? 5 twos are 10. 5 ones are 5. 6 centimeters. Is it clear? 6 centimeters. Find B dash, C dash. Check the answer in textbook, student. See how easy it is. If you have understood the concept, it is very simple to solve the question. All of you will complete it and check the answer in textbook. Be quick. I want you all to write in the same way, students. Draw two diagrams. Remember this TXO. Transformation is equals to X into original. Okay, what's the answer? Evander? The answer in text. Is it correct? Okay, next. Yeah, next one, students. Which one we need to find? Transformed image B dash C dash is equals to B. B dash C dash as it is, K value is 5 by 3. This K is the most important part. Scaling factor. Always start with scaling factor. In some questions, scaling factor will be given, students. In this question, it was not given. We found it. Okay, 7.5, 4.5. And how did I teach all students? If you want to remove the decimal, add 10. Look here, 5 ones are, 5 twos are. 3 ones are, 3 15s are. 15 divided by 2 is 7.5. What is given here? Centimeter is given, so write centimeters. Size transformation. Look at the next one, students. Tell me the next one. Be quick. ABC with side BC is reduced, right? Reduced. So try this question. Complete all of you all. Find the K factor. I'll do the third one. Sides are given. Area is not given, so keep K as 1. Complete the second one. Draw the diagram first. A, B, C. This is the original one. AB is 16, BC is 12, CA is 18. It's reduced to meaning is small. See, I'm drawing a smaller diagram. A dash, B dash, C dash. Okay, in this, which value is given, students? ABC such as the smallest side. Which is the smallest side in the original diagram? Which is the smallest side? So with relative to that, B dash C dash is how much? Yeah, start from BC, all of you all. Start from BC. Find the K factor first. Find the scale factor and use it. Lemula understood? Mariana, Lemula, Cherisha. All of you all have understood, right? So the transformed image is B dash C dash, students. Here the transformed image is different now. Take B dash C dash is equals to K into BC, original image. Reduced. A dash, B dash, C dash is the transformed image. So therefore BC is equals to 4.8 divided by 12. 48 divided by 10 into 12. Did you get 2 by 5? Look at the calculation part. Not BC, students, sorry, not BC. K value is 2.5. BC is 12. Okay, not BC. K value is 2 by 5. Use that and find the other values. Okay, last question. Remaining 8 questions, we'll do it evening. Remaining 8 questions will complete. Tomorrow I'll be starting new chapter. Yes, check the answer in textbook here. Is it correct? Okay, what is A dash, B dash? Do it with the diagram, students. If not, they won't give marks. 6.4, right? All of you got 6.4. Okay, if you're still doing it, complete it. Complete. See, 9:30 students. 9 o'clock I felt early. I'm keeping it 9:30. Even 9:30 if you're attending late. See, same like Joanna. Today you'll have to watch the recording. What's the next answer? 7 point. Is the answer same in textbook? This are the answer, students. Then write it what they've asked here. Use the length to find A dash to find the other side. Okay, we found the other side. In the last, write scale factor. K is equals to 2 by 5. That is the scale factor. And write all the other values. Complete the answer. Mostly you might get it for 3 marks. Very easy concept. Fine. If you understood the basic, this is easy. If not, you'll get confused. What is transformation? Original image, reduced image. K is equals to 1, greater than 1. Okay, that's it for today. This class, log in at 6 o'clock, all of you all. Those who join late, go through the recording. All of you all can leave.